How serendipitous that Raul and I we had our talks together. I want to build and continue on your thoughts in here. You're right, data is exploding exponentially. We spoke of Internet of Things and the data that those sensors put out. Martha mentioned Internet of Everything earlier that we started, and that takes it even a step forward. Medical records, MRIs, CAT scans, cardiograms, doctors' notes. What about the social media, blogs, tweets that are proliferating the entire data pool that we're calling big data? There is something quite peculiar about this data. 85% of it is unstructured. It doesn't just happily live in a database within tables and columns and rows that you can call with a SQL clause and force it into a rules-based engine and detect an outlier out of those. It doesn't. Extracting knowledge from all this unstructured data is really the domain of cognitive systems. Think about, and it isn't enough to just measure the synthetic measurements that we get about it. We want to extract the semantics behind this. We want to get insights behind the personality traits of the author. We want to analyze the tone of an email that went out. Lord knows I could use that particular API. The sentiment analysis, discover patterns. It's one thing that you have a question and you ask of a system and you get an answer, but it is another thing that you don't even know what it is that you don't know. And you extract that concept, that particular insight from a cognitive system. Well, how does cognition work? Let's take us as humans. We observe our environment. We interpret that in which we see, with our biases built in it. We evaluate. Not all the considerations are of equal saliency. And we decide. We decide based on those. We advise based on those. Now, while doing so, experts are built. We spoke of experts. I think it was Michael Bernstein, crowdsourcing we were talking about. How does one become an expert? It's really through repetition. It's through hands-on exercises. But experts, what they're missing for that matter is this deluge of data that's not always at their fingerprints. That's exactly what you were saying, Raul, earlier on. So these are the challenges that the experts are facing. Here's an example. My mom gets swollen ankles. And she sees many different doctors. There is a diagnosis that it might be because of her kidneys. We've heard from other doctors that it's because of cardiovascular, because of her circulation, poor circulation. Well, do these doctors have access to her history of medical records right there at the moment she walks in? Does anybody ask her that, funny, you only get that in the summertime when it's really humid? And these are the expertise. It is this advent, this access to it, having that pad that you walk in, and without, this is not a thing of upload or download, really. This is a matter of existence, the semantics that is gathered from not just text, but also images that would help lawyers, finance sector, medicine to be able to then infer further remedies. Let's take a look at this. Wise man gets a positive sentiment. A wise guy gets a negative sentiment. Noses that run, feet that smell. There are annotators, bigram, trigram, skipgram, n-gram. These annotators, they build affinity between words naturally. So there's a strong affinity between nose and smell, strong affinity between feet and run. I hardly say, oh, look at him, what a powerful guy. That's a strong engine. No, it's a strong guy, and it's a powerful engine. So Watson needs to understand this. You see, this is not a matter of translation into a different language. For Watson to speak in Spanish, it needs to think in Spanish at the annotator level, at the algorithm level. We've done some fantastic work. I want to give you a few examples. Africa. It was who were we chatting with that was doing some work in Africa? I wrote that in here. It was Dr. John Wilinski. He was doing some work in Africa. We are trying to, speaking of collaboration, speaking of platform, Nairobi and Kenya. Those are two cities that we are engaged. So it's a pilot program. The students have, they're given paths, and of course the interface is quite simple. Exactly the same interface that Abby King was talking about, that she gave to the folks that would record their transactions. So they sit in the classroom, and the teacher has a dashboard that sees, records all the events that are taking place. All of a sudden, she notices that she has gone past a certain topic, whereas everyone else in the class is still stuck behind. Through analytics, through prediction, they noticed that the reason that the students aren't coming to class is because there aren't enough chairs. It's because the distance is too long. It happens whenever electricity is out for a number of days. Now that I have this insight, how can I move forward? How can I collaborate with the Ministry of Education, with the teachers? The platform economy, if you would, is needing the API economy. Raul was talking about the API economy. I mean, these are very much intertwined together. Another great example, in medicine. Baylor College of Medicine has been working on protein P53. The job of protein P53 is to repair damaged cells, or if it's not going to repair it, kill the damaged cells. Through mutations, environmental factors, smoking and the good life, P53 goes through this mutation that stops its job of actually cleaning up the system. So the cells proliferate out of hand. They came up to Watson. They said, oh, so you've got a product that you say is going to do a good job with discovery. It has taken us 7 years to find out 6 amino acids that are directly related with this particular work. Let me see if you can find it. Now, Watson, needlessly, it went through, there's a training period. Corpus was ingested, CDC, American Journal of Medicine, and so forth and so on. It found those 6 plus 2 more amino acids that are directly related with the work that P53 does. Another area we're having fun with, Minecraft. You know, Minecraft, it's about discovering. It's about building. It's about surviving. Now, how cool would it be if you have a cognitive system, an advisor, that actually advises you, gives you insights, predicts about the discovery you're about to do? Does, what is the better of 2 evils? You know, it's which direction should I go? They're both bad, one of them is less bad. Well, this is great. Robotics. No, I usually say in my talks that cognitive computing is about the 3 L's. Language, do you have an NLP stack? Learning, do you score and rank the results? Not everything is of the same value. Language learning and an understanding of it. The 4th one is limbs, robotics. Japan, we're working with the SoftBank in Tokyo. You know, when it comes to robotics, they're number one in building the system. How cool would it be if the head of this robot was actually a cognitive system connected, certainly through the internet, to the data centers and so forth. Go Moment is a company that's in Santa Monica. And they are working on trying to put cognitive on a robotic humanoid system in the Hilton hotels. So to answer questions, and the questions that we pose the system are in natural language, with those idiosyncrasies and the idioms. Just the natural way that we speak. It needs to tokenize, parse, and annotate, and retrieve an intelligent result with a high confidence. This was, while I was sitting back there, I wore my solution architect hat for a bit, and I begged Dr. Abby King to stay, but she had to go. Remember Abby's story about walking, about measuring the progress of the folks that are undergoing hardships in life of various means and ways through health-related searches. So imagine all of a sudden, so they are recording their activities through the pad. There is a dashboard, and say Dr. King is able to see that what's going on and patterns and so forth. All of a sudden, she realizes that those who live on 3rd Street, she's got a bunch of people that live on 3rd Street, have stopped leaving the house. They're not going for a walk anymore. They're not going to type in there, I can't stand that hill, because they're on a hill. Or they're not going to type in there, the reason I'm not going out for a walk anymore is because I get harassed by the homeless people. But if we get that insight through an image analysis, so a hill would garner a negative sentiment. This feedback goes back to the beginning, goes back to the administrators, and now maybe they can decide and say, you know what if I send a bus over and collect the folks that are on the 3rd Street, take them to a park? I did not know that. Nobody said that it's because of the hill. I can't do this anymore. Solution architect at the moment. This is my final slide. Our machines should be nothing more than tools for extending powers of human beings who use them. Something to bear in mind, it's an interesting thing. These machines, they are founded, they're probabilistic systems. They're not deterministic systems. This computer is a deterministic system. There's a code, and it's either true or false. If there's a wrong answer in here, well, then I need to see what the function didn't call a certain method and go fix the code. Cognitive systems are probabilistic. They employ 2 types of learning. And forget the slides, I'll tell you a good story. There are 2 types of learning. There's supervised learning, and then there's unsupervised learning. Supervised learning uses logistical regression. Martha loves statistics, log-based too. Unsupervised learning, that's neural networks. It uses vector graphics. Example, supervised learning. Let's say I decide to become a dermatologist. I've had a great time in IBM. No, I'm going to stick with IBM, it's fun. But let's say I decide to become a dermatologist. So I walk around the house and I say to my wife, honey, I'm going to be a dermatologist. She says, you know, you need to study a lot for this. I said, oh, I can do this. So I go and bring in a lot of books from the library, develop a corpus. And then she says, that's great. You have a lot of books on the table, but have you even opened them? Have you studied them? Okay, fine, I'll study them. So I go through every chapter and every section, do the little quiz at the end of the chapter. Ground truth development is what we call. So we feed the system thousands, 2,000, 2,500, that should do for statistical questions. We match them with answers. We tell them, look, this is a question, this is the answer. I'm going to run a statistical model on you, get my patterns. After all, that's what machine learning is all about, patterns. And so next time when you see a question you haven't seen before, you'll be able to answer it. Blind set test. That's when I take the medical board exam. In between, it's an iterative process. I take the test over and over again. I take the little quizzes over and over again before I go take the big test. And this is the exact same way that supervised learning takes place. Unsupervised learning. We have a family, they have a 2-year-old, not me. I mean, ours are grown. I don't know what happened, but the shoes, I can't even get past the hallway now. A family has a 2-year-old child and they bring home a dog. That's a dog. Great. Next day, exactly next day, they go over to neighbor's house. The neighbor also has a dog. Different looking dog. Entirely different looking dog. The child doesn't freak out and go, oh my God, what is this creature? It knows that it is a dog. I want my machine to learn like that. I didn't go through this entire process of iterativeness. So neural networks, it comes into play. The lowest level of abstraction, faces, for example. How does it know that's a face and not a car? Lowest level of abstraction, it looks at edges. It says that's an edge. It's one heck of an edge. And that's an edge. That's all I know. I got 2 edges. The signal jumps literally from a neuron onto a node, onto the next level of abstraction, lower level of abstraction, even though it's higher. And now it sees this, and it sees a circle. About 10, 12 levels further, it's got a face. So whenever this picture of a person is taken, if you guys hang around, I'd love to perhaps demo that in one of our services later on. We'll drag and drop a picture of somebody we know and somebody we don't know. Let's see how far it can get. And it comes back and says, that is a face. Thank you very much, folks.